Okay, in this video we'll be reviewing quadratic equations. We got the graphs at the start. We have to graph the function for x and y. We have y equals x to the second power minus 4x plus 3. Now again, anytime x is to the second, it's going to make a u. Now the reason for that is if you take negative 1 to the second, 0 to the second, and 1 to the second, negative 1 to the second is negative 1 times negative 1, and that's positive 1. 0 to the second, 0 times 0, that's 0. And then 1 to the second is 1 times 1, that's 1. Okay? So it starts, goes low, then goes up again. So that's a u. So we have three coordinates we have to figure out, with of course the most important being the vertex coordinate. Get something written down here so that it matches u. Okay, now how you find the vertex for the x and the y, it depends on the formation of the equation. Here we don't have any parentheses, so this would be an ABC form. So I would apply a 1 there, that's my A, and then B, and then C. So on ABC form, the way to find the vertex is this little formula here, the opposite of B divided by 2 times A. So opposite of B, 2 times A. So the opposite of B is positive 4. Then on the bottom we have 2 times 1, and that's 2. So 4 divided by 2 is 2. So then we take that 2 that we just came up with, and we add and subtract 1. So 2 plus 1 is 3. 2 minus 1 is 1. So those are your three coordinates for inputs. Now you have to find the outputs. You simply substitute those values into the equation for x. So I take 1 times 3 to the second. That's going to be 9, because 3 times 3 is 9, times 1's 9. Minus 4 times 3, so it's 9 minus 12, we're at negative 3. Then plus 3, I'm at 0. Okay, now I substitute 2 in. And I come up with negative 1. Then when I substitute 1 in, it should be back to 0. Well, 1 to the second is 1, times 1 is 1, minus 4, plus 3, and that takes me to 0. Okay, so 3, 0, 1, 2, 3, x-intercept, then 2, negative 1. You need to label that point, because that's your vertex, okay? And then 1, 0. So now the reason why it's important to label the vertex is because now you can identify the domain and range. So your domain, now look at that, look at the x. Now you're higher than 2 and lower than 2, so that means that the domain is all. Okay. Now the range, you put your negative 1. Now I have a question, these zeros I got, that's higher than negative 1, isn't it? Okay. So y is higher, great, you eat the y, okay? Because if I put a 0 there, that's always bigger. And also when it goes up, you're going to have a greater than or equal to negative 1, because all your y, you see your x can be anything, okay? But the negative 1, you know, it starts here and goes up from there. It never gets lower than negative 1, only higher. So higher means greater than. Okay, we have y equals negative 3 times the quantity x plus 5 to the second power, and then minus 6. So again, x to the second power is a u. I need to find my coordinates. Okay, vertex being the middle. So this isn't ABC though. When I have one parentheses with the x inside to the second power, it's AHK. So A is the multiplier. Then h is 5, k is negative 6. So we find the middle by taking the opposite of h. It says so right there. You don't do any operations, you just make your positive 5 into a negative 5. Then we take the negative 5 plus minus 1. So that's going to be negative 4 and negative 6. So then I insert negative 4 in for x. Now if I look at this, negative 4 plus 5 is 1, 1 to the second is 1, negative 3 times 1 is negative 3, and then subtract 6 from negative 3, you're at negative 9. Now, you can put negative 5 in, but you're always going to get the k value every time you do that. like I said. The reason why it's k is because that's 0, 0 to the second 0, 0 times negative 3 is 0, but at the end when I'm subtracting the 6 from 0, that would be negative 6. Then I put negative 6 in, and I get negative 9. Okay, so negative 4, negative 9. So this is x, this is y. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Just go right there. Okay. Or no, go by 2's. Then you can hit it for sure. 1, 2, 3, 4, 2, 4, 6, 8, and then 9's, negative 9's right there. Okay, negative 5, negative 6. 1, 2, 3, 4, 5, 6. Or no, 1, 2, 3, 4, 5, 2, 4, 6. And then here we're just going to get negative 6, negative 9. So as you can see, sorry, I'm struggling here. There's the graph, okay? It opens downward because the A is negative. Anytime the A multiplier is negative, you can expect your parabola to open downward. So label the negative 5, negative 6. And we need to find the domain and range. So negative 5, but you're lower, higher and lower, so that's going to be x equals all. And then the range, you put that negative 6, but that's not all, because negative 6, it goes downward. And you can see on the graph, those values are less than negative 6. So less than or equal to. Okay, so you'd eat the negative 6. Negative 6 is higher than negative 9. See, because if I put a negative 6 and a negative 9, it would eat the, a negative 9 and negative 6, it would eat the negative 6. So that's like the y value right there. Okay, next problem. We have negative 2 times the quantity x plus 4 times the quantity x plus 2. Find the right thing on the document here. Okay, so x in each quantity is going to be a u, because that's x to the second. And we need to find our vertex point. So xy, xy, xy. Now, APQ that. Okay, so opposite of P, opposite of Q, we want to find the outer coordinates first, because the outer coordinates are going to be the x-intercepts, so negative 4 and negative 2. Okay, so if I put negative 4 in, negative 4 plus 4 is 0. So if I got negative 2 times 0 times whatever that is, it's negative 2. But 0, that being a 0, means that the output is 0. Now negative 2 plus 2 is 0. That would make our whole output 0. So negative 4 is 0. And then negative 2 zeros right there. Now I substitute to find the vertex. I need to add these two because the vertex is going to be halfway in between those. So you're going to add negative 4 and negative 2 and divide by 2. So negative 6 divided by 2 is negative 3, halfway in between. So now we substitute negative 3 in for the x's. So negative 2 times negative 3 plus 4, then negative 3 plus 2, and that gives me a 2 output. So negative 3, 2, 1, 2, 3, 1, 2. Once again, the A is negative, so I expect it to open downwards. So label your negative 3, 2. That's the vertex. And now we use that to kind of analyze what we have for the domain and the range. Okay, so the x, you're lower and higher. Okay, so that's all. Now with the range, you're not lower and higher, you're just one direction, you're lower, okay? So if I were to put a 0 here, you'd have to eat the 2, so it'd be less than or equal to 2. Okay, y equals negative 2/5 x plus 4. Now there's no second power, so now that x is not to the second power, it will just make a straight line. So we get the y by itself if it's not already, it already is. So mb and then slope y-intercept. So the slope is negative 2/5, positive 4 is the y-intercept. Then from there we go down 2, 4, down 2, 1, 2, 3, 4. And then the domain and range you don't have to do. You can either just leave it blank or you can just cross it off because there'd be no restrictions on the domain and range in a line. Okay, now we're solving equations. Now, when you solve equations, it's very important to know if you're using the factoring properties we studied or the linear properties. Well, I have to solve for the x variable, but we have x to the second and x to the first. So that's the same variable, but to two different degrees. So you have to use factoring properties. So there's two answers because of the x second. Now you make sure you're equal to 0, and now you count your terms. There's 1, 2, 3. This is not a negative, it just got a scratch mark. Okay, so 3 terms is GCF table. Okay, so there's no x on the end, there's no negative in front, then 1, 5, and 4 would just be 1. Okay, so ABC. 1 times negative 14 is negative 14, so the signs have to mismatch. You're trying to find two factors of negative 14, so that'd be a positive times a negative, and it's got to add to the b value the two factors do of negative 5. So 14 divided by 1 is 14, that's negative 13. 14 divided by 2 is 7, and you add those, there's your negative 5. So the a is 1x to the second power. So you put your positive 2, your negative 7, and then we know this x to the second is x times x. And then I apply that 1 in front of the x's, but then those really can't be divided down, they'd just be 1's. So it'd be 1x plus 2 and 1x minus 7. Equals 0. So take the 1's off the front of the x's, okay? And you'd have, or no, you put the 1's there, sorry, don't take them away. F1, F2, I mean you can take it away if you want. 1x plus 2 equals 0, 1x minus 7 equals 0. So we got multiplication by 1, so we have to subtract 2 first, and that would take us to negative 2 on that side. Then you don't need to really divide by 1 because it would still be negative 2. So that's why if you have a multiplier of 1, you don't need it. You just add 7, and that's 7. So negative 2 and 7. Okay, next problem, 4x to the second power plus 20x equals 0. So we have x second and x, so again we have to use our factoring properties. So there are two answers for x. Okay, 0's there, you can check that. And now you're not factoring 3 terms, there's only 2 terms. So 2 terms is a binomial, so we check for the GCF and the difference of perfect squares. Okay, so x on the end, absolutely. Negative in front, nope. And then 4 and 20 would be divisible by 4. Okay, so I'm going to divide by 4x. So that's going to give me 1. Now x second divided by x, we get a cancellation with a remainder of x. 20 divided by 4 is 5. And then x divided by x is actually cancels. It's actually 1 when two variables cancel, but then 5 times 1 would be 5. So I bring over the 4x. Now I check that second parentheses and see if that's a difference of perfect squares, which it's not because you have positive, positive. To even go on, you have to have a positive, negative. Okay, so we write no, it's not a difference of perfect squares. And then we put the 1x plus 5 next to it. So F1, F2. So 4x equals 0, 1x plus 5 equals 0. So you divide by your 4 here and you get 0. You don't need the multiplication by 1, just get rid of it and subtract 5, and that's negative 5. Okay, next problem, we have 3x to the second power minus 17x plus 20 equals 0. So we have x second along with x. So again, we use the factoring properties. So there would be 2 answers. Zero's there. Anytime you're using factoring properties, you need 0. Now you count your terms, and there's 3. So we know from the previous problem, a couple problems back, that's GCF and the T-chart. So no x, no negative, 3, 17, and 20, that would just be 1. So we would not end up doing that. And the AC product, 3 times 20 is 60. Now it's positive. So the signs now have to match, because if we're finding 2 factors of positive 60, we need a positive times a positive or a negative times a negative. I'll start with negative, negative, and that's way it'll stay, because you have to add to negative 17. 60 divided by 1 is 60, that's negative 61, that doesn't work. 60 divided by 2 is 30, that's negative 32, that doesn't work. 60 divided by 3 is 20, okay? That's negative 23. Now you cannot make the 3 positive and say, yeah, now it's negative 17. No, you can't, because then it won't be a match, okay? Because see, positive 3 times negative 20 is negative 60, okay? We have positive 60, and that can't change, okay? So this ain't it. 60 divided by 4 is 15. We add those, I get negative 19. 60 divided by 5 is 12, and we add those, you get negative 17. So negative 5, negative 12. Now your A this time, the x second has a 3 as a coefficient. So we go x, and we place the 3 in the front. Okay, now 3 and 5 can only be divided by 1, so that won't change. 3 and 12, however, can both be divisible by 3. 3x minus 5, 1x minus 4. Now you delete that, all of it. See, 3 times 1 is 3, yes. Negative 5 times negative 4 is positive 20, so yes. So we have 3x minus 5 times 1x minus 4 equals 0. So 3x minus 5 could equal 0, or 1x minus 4 could equal 0. So multiplication by 3, we need to add the 5 first, and that's 5. So we divide by 3. 5 divided by 3 is a decimal, a pretty crappy looking decimal, so you can go second PRB to get 1 2/3, or you can just leave it 5 over 3. It doesn't matter, but I don't want that decimal that repeats. Times 1, you get rid of that, plus 4 plus 4, and I get 4. So 5/3 and 4. Okay, 2x to the second power minus 33 equals 17. Now this time we have x second only, so there's only a single degree of x. Okay, so we don't want to use the factoring properties, you want to use the linear properties. So linear properties, fill out how many answers there are, there's 2. Collect the x terms if you have more than one. Well, we just have the single one. Now you solve using the linear properties. So you have to analyze the operations you have on the x side. You got times, that's a power, minus 33. So circle the times. So these are the linear properties. It's inverse operations. So you get rid of your minus 3 with plus 33. You get rid of your times 2 with divide by 2. And then you get rid of your second power with a square root. It has to be in that order. So I add 33, and that takes me to 50. Then we divide by 2. That gives us 25. then I find the square root of 25. Now what times itself is 25? If you don't know, you square root it on your calculator. If you do know, it's 5. But it could also be negative 5. So 5, negative 5. Okay, next problem. 5x to the second power plus 30x plus 32 equals 0. So I have x to the second and x. So again, I have to apply my factoring properties. So there's two answers. And we have the 0. Now you got three terms. It's a trinomial. So GCF and the table. So no x, no negative, 5, 30, and 32. Well, it's either going to be 5, 5 and 30, but there's no 32. So it would be 1. So I would not do that. So the AC product, 5 times 32 is 160. Now it's positive, but read this. If the sum is too narrow, or you start greater than 100, then you can use the quadratic formula. Okay. I should also add to that if you repeat the same factor and haven't found it yet. So if I have like a 3 and a 5 and that ain't it, getting a 5 and a 3, I can stop there because I'm just repeating myself. Higher than 100, go to the quadratic formula. So x equals opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of positive 30 is negative 30. And then b is 30 to the second, and then a is 5, and c is 32. And a on the bottom is 5. So you have negative 30, and 2 times 5 is 10. Now you make your square root, and to find what the value inside of it, you have like a little problem inside of it to solve. Just order of operations, you take, that means 30 times 30 minus 4 times 5 times 32. Okay, 260. So that could be positive or negative, and then I find the square root of 260, and I get 16.12. And that is a number you add and subtract. Negative 30 plus 16.12, click equals, then divide by 10. Negative 1.39. Then I take negative 30 and subtract the 16.12. Then I divide by 10, and you get negative 4.62. Okay. Next one, 4x minus 3 equals negative 2x plus 12. So we have x to the first, then another x to the first, so that's x only. So again, only one single degree, you want to apply the linear properties. Unlike the first one though, this one would have one answer. And unlike the first one, we got some x terms we need to collect into one. So they're on opposite sides, take out the smaller one. And now I have 6x minus 3 equals positive 12. So now you apply your linear inverse properties. So you plus 3. You would then divide by 6. You would not need to square root here though. So plus 3, that's 15. And divide by 6, and that's 2.5. Okay, next problem, we have x to the third power minus 6x to the second power minus 16x plus 96 equals 0. So we have x third, x second, and x. Obviously, you're going to have to use factoring properties. You have 3 different degrees of x. So there's 3 answers. Okay, 0's there. And now we have 4 terms, so that's a quadnomial. Okay. So it's the grouping and then the dots at the end. Grouping. Then the same thing with GCF lines. then little parentheses, big parentheses, and of course we check the big parentheses for difference of perfect squares. Okay, so we put 1x third minus 6x to the second, then we put negative 16x plus 96. So we have x second at the end, we don't have the negative in front, 1 and 6 would be 1. There's no x here, you would have a negative now. Then 16 and 96 are both in row 16. Okay, so you're going to divide by 1x squared here, and you're going to divide by negative 16 here. So that's 1, x third divided by x second. You have a remainder of x. Negative 6 divided by 1 is negative 6, and the x second divided by the x second cancels completely. It's 1, but then negative 6 times 1 is negative 6. And we're going to get the same thing here, 1x minus 6. So we have 1x minus 6 within both the parentheses. And then outside we put the 1x to the second with the negative 16. So you don't really need those 1s that are in front of the x's. You can bring over your x minus 6. Now, is this a difference of perfect squares? Well, it's positive, negative, so it's a difference. Now, is x second a perfect square? Yeah, it's x times x. And then 16, 4 times 4. So that's x, 4, 4. So instead of putting that next to the x minus 6, we put x plus 4, x minus 4. So F1, F2, F3. So x minus 6 could equal 0, x plus 4 could equal 0, x minus 4 could equal 0. So we add 6 and we get 6. We subtract 4 and we get negative 4. And we add 4 and x equals 4. Okay, now we have x in a quantity. You put that away, that's not going to help you. So you make the quantity and put what's inside. Now, is there a power outside? No, there's not. So this is an easy one. You just distribute like you normally would. So there's one answer. So 5 times x, 5 times negative 3. So this can be 5x plus negative 15 equals 10. Now I apply my linear inverse properties. So we'd have to plus 15, and then we'd have to divide by 5. So that's 25. 25 divided by 5 is 5. Okay, now the next one we have an x in a parentheses, but if you look carefully, sorry, put that up here. That parentheses, the quantity is to the second power. So that means you're blocked. You can't distribute. Okay? So you're going to use another variable with h. So you're going to have 4 times h to the second equals 28. Okay? Now you got to remember the end game is to find the two answers that x would have. There's two answers because x is to the second power. But first you have to find the value for h, and then after that's found, you're going to use that table where you bring back the x plus 2 twice. Now you need twice of them. You need 2 of them because when I solve for this, okay, when I solve for the h, I have to divide by 4 and do a square root, and the square root always leads to the positive and the negative. So then you divide by 4 and you get 7. Then you find the square root of 7, so that could be positive or negative. And the square root of 7 is 2.65. So we'd have 2.65 and negative 2.65. Now I solve for the actual x. See, what I'm doing when I bring that h is I'm solving for the x plus 2. Now I solve for the x by getting rid of the plus 2. So 2.65 minus 2 is 0.65. And then negative 2.65 minus 2 is negative 4.65. So there we have it. Okay, now story problems. An object is thrown upward from a height of 15 feet at a velocity of 35 feet per second. After how many seconds will it land on the ground? So I'm solving for seconds. And seconds in that problem is also related to feet. So we apply x is seconds, y is feet. X is always the time, y is a function of x, and anything's a function of the time. So per feet per second. Feet per second is 35 times x. Now, even though that's the rate of change, it's not the rate of change for infinity, okay? So this goes up, and it comes down, slows to a pace, then comes down, and it's pulled by the force of gravity, which is negative 16x to the second. Okay, so you have 15 feet at the beginning, and then it lands on the ground, so I assume that's 0 feet. Then I put a question mark with that, seconds. That's the answer to the problem. So we have to have an equation where we can solve for the x. Okay, so that parabola means you're going to have an x second in x and a constant equals y. So negative 16 and then 35, and then we start at 15. So there's the equation. So 0 feet needs to go into that equation, and it goes in for y. Okay, now I solve for x. So we have an x second and an x to the first. So you have to use factoring properties. So two answers. Zero's there. So you're set. You have a trinomial with 3 terms. So that's GCF and the table. So no x on the end, negative in front. Yep. Then 16, 35, and 15. So we can't do 15, okay? Here's 15 again. We can't do 5. 15, no. So I think it's just 1, but it's negative 1, so you should go ahead and do it. So go up and divide by negative 1, and all that does is change the sign. 16x to the second, negative 35x, negative 15. So ABC. 16 times negative 15, negative 240. Now that's above 100, so I'm not going to try to factor it. I'm going to just go to my quadratic formula. If it's under 100, you need to at least try to factor it. If you end up too narrow, then you go Q up. But when you start at 200, I can just go here. So opposite of B, plus or minus the square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. So the opposite of the b is positive 35. B to the second, that's negative 35. And then a is 16, c is negative 15. Then a on the bottom is 16. Okay, 2 times 16 is 32. And then 35 in front. Now you got to find what the square root is by plugging the inside. So negative 35 to the second, subtract the product of 4, 16, and negative 15, 2,185. Now I find the square root of that. So the square root of 2185 is 46.74. Okay, so 35 plus 46.74 equals, and divide by 32, 2.55. Then 35 minus 46.74, click equals, divide by 32, negative 0.37. So 2.55 is the answer we want. So at 0 feet, it took 2.55 seconds. Okay, a go-kart track has 380 racers and charges each racer $35 to race. The owner estimates there will be 20 more racers for every $1 decrease in the price per racer. How can the owner of the go-kart track maximize weekly revenue? Okay, so maximum is finding a vertex in an equation. Okay. Now, if you remember from your graphing on the front page, to find the vertex, we usually go with this equation without the parentheses. That's opposite of b divided by 2 times a. So we know that that's a formula we need to use. Now, don't waste time doing the units analysis with the boxes. Just make your centered parabola and make an xy coordinate, and under the x you put opposite of b divided by 2 times a. Okay, so we need an equation obviously now. So we know we need an x second, an x, and a constant. But this doesn't stand for height, so that negative 16 stuff's out the door. Y now stands for revenue. So you need a couple quantities here. Think of it. Let's say I'm selling like pizzas. I sell every piece of pizza is $2 and I sell 10 of them. Well, 2 times 10 is 20. So you're taking the dollars times the number of items you sell, but the dollars are changing and so are the items. Now to know how to fill that up, I would make your table, dollars and items. So the dollars start at $35 and then the items, in this case races, would be 35, not 350, would be 380. Now what's happening to the money amount is we're subtracting 1, and every time we subtract 1, 20 more racers come in. So now this would be 34, and then this would be now be 400. Then I go down a dollar again, 33, and this would be 420, and that goes on. I just need 3 rows. Now, essentially what we're finding is when does the max revenue reach its highest point. So 35 times 380 is 13,300. You can write this or not. It doesn't really matter if you write that. You need the table. But 34 times 400, that's going to be 13,600. So the revenue has went up. 33 times 420. 13,860. Now it went up again, not by as much, but it still went up. Now when does it quit going up? We don't know, because eventually it will quit going up. Heck, if you ran that all the way to 0, then you'd make $0. But now I know how to fill this parentheses up. We have 35 and we have 380. Then subtract 1x, because we don't know how many times, and then here you're adding 20x. So you have to run the FOIL method. So 35 times 380 and 35 times 20x. Then negative 1x times 380 and negative 1x times 20x. Okay, so 35 times 380 is 13,300. 35 times 20 is 700 with x. It'd be x with negative 380. And this would be x to the second multiplied by negative 20. Okay, because you times. So negative 20 is my a. Then I collect my x's, combine them into 1. That's 320. That's your b. Then 13,300 is your C, but I don't even bother labeling C because I just need the A and the B to do my opposite of B divided by 2 times A. So opposite of B is negative 320. Then 2 times negative 20 is negative 40. Then I divide these and I get 8. So on my table I just see 1, 2 changes. Well, there'd have to be 8 changes before you finally got that to maximize. Okay. So 8 changes. Now you find your money amount by substituting the 8 in for the x's. Okay, so negative 20 times 8 to the second plus 320 times 8 plus 13,300 equals y. $14,580. Okay, so $14,580 is your maximum revenue. Okay, then on our last problem, this is shape. You have a 10 by 9 foot garden. If you add a uniform walkway around the garden, the area is 306 square feet. Find the width of the walkway. So when they're talking about shape, we want to draw the shape. Now I know my length and width inside's 10, but we're building a border around the outside. So recalibrate the dimensions of the whole thing. So you got a 9 and a 10, okay? Actually, if you want to put 10 by 9, that's probably the correct one, but it doesn't really matter, okay? If you get those flipped like I did, it's not going to matter, but I want to be consistent with where I'm telling you to put stuff. So x, and I'm finding the value for x. So then I make my side box, and since they're telling me the area, so length times width equals area. So the length, 2x plus 10. The width, 2x plus 9. And the area is 306. Okay. Now you have to execute the FOIL method. 2x times 2x and 2x times 9. Then 10 times 2x and 10 times 9. So that's 4x second, 18x, 20x, and 90. So now simplify your product. So we have 4, that's going to be 38, and that's going to be 90. Okay. So 4x to the second plus 38x plus 90 equals 306. Okay, so I have x to the second and x here. So obviously you have to use your factoring properties. So there's two answers, but you need your 0. So you subtract 306, and you got x second, x constant equals 0. So you have 4, 38, and then 90 minus 306 is going to be negative 216. So it's 3 terms, so GCF and the T-chart. X on the end, nope. Negative in front, nope. 438 and 216. Well, 438's not here. Now 4's up here and 38's here, but then I run out of space at the 216. So the row is 2 that I'm looking at. So if I run out of room, I take all these divided by 2. No decimal, no decimal, and no decimal. So 2's got to be the one you roll with. Okay, so it's going to be 2x second plus 19x and then negative 108. So take that 2 and just bring it over here. But the AC product is negative 216. Well, that's well over 100, so put QF to that. So opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So opposite of B is negative 19. And then B is 19 to the second, and then A is 2, C is negative 108, and A on the bottom is 2. So we have negative 19, 2 times 2 is 4. Now we make our square root. Okay, now we got to figure out what goes inside. So inside that square root, we have a 19 to the second. I need to subtract the quantity of 4 times the quantity of 2 times negative 108. Now I got 1,225. Then I find the square root of 1225, and that's 35. So that's the number you add or subtract. That means the T-chart would have worked if I would have actually had the patience to do it. Divide by 4 and you get 4. You add, click equals, divide. Then you take negative 19 and subtract 35, click equals, divide by 4, negative 13.5. So 4 is the answer we want to take. It'd be 4 feet.